Hello, everyone. Welcome. I'm James Ward, do Agentic AI stuff at AWS. This talk is about Spring AI. We have the illustrious Josh Long with us, still getting his demo ready to go, as usual. And then we have Christian. You want to say hi?
Hello, guys. Yeah, great to be here.
What do you do?
So I'm part of the Spring team, one of the co-leads with we're leading the Spring AI project with Mark, and as of recently, I'm also a maintainer with Darius and Daniel of the Java MCP specification. So that's what I'm going to talk about today. So
great. And
exciting projects, yes.
Yeah, it is.
Yeah, I'm Mark Pollack. I helped create the Spring AI project, and I'll be talking today at the end about our sandbox community where there's new agents and benchmarks for AI agents.
Exciting. So let's see, how are we doing, Josh? Still working.
We forgot one very important thing, and worst case, we can just drive this particular chunk with your laptop.
That's right. Well, oh, amazing. Okay, you got it.
Mercy.
Plug in. Let's go.
Oh my goodness. Okay.
That was right in the nick of time.
Right in the nick of time. Okay, here we go. Okay, here we go. All right. Come on.
Welcome.
Is that doing the thing?
There we go. There we go.
Oh, good. Hi, everybody. Oh, wait, you get over here. Come here. You two. I just got one job. We need a selfie. Oh, come on.
Selfie.
We're professionals. Don't worry. It'll be fine.
Make it fast.
Okay. Okay. Everybody, just pretend like you're happy. Quick.
I'm pretending.
Take a selfie, everybody. Come on. Just. I need the energy. Okay, here we go. Come on. Ready, steady, say open source.
Open source.
Open source, MCP.
MCP.
Okay, now shoo. Okay. Bye. Okay. Hi, everybody. This is arguably the most important slide you're going to see in the next 25 minutes. Is this right here? Insofar as it's the only slide you're going to see in the next 25 minutes. So there's that. I'm Josh. You're James. You already met the Spring AI team.
Crew.
Oh goodness, are you excited?
I'm excited. We got some code to write. We better jump in.
We gotta jump into it. You know, we're not gonna get very far unless we have an actual account, right? And so first things first, we're gonna talk about Spring AI. We're gonna talk about all that is and will be, but we need to make a decision before we can dive right in. One of which is which model should we use? Okay. And I don't know. You know, we have a portable service abstraction, lots of starters that you can use to make that choice if you want. But today, I think a really good choice is Amazon.
Sure, why not? Yeah, we can use
Bedrock.
Amazon Bedrock. So you can use with Spring AI whatever models you want, and lots of different support for those. We are using Amazon Bedrock, and we are in the console, and we're able to go down and go to this model access thing where we can see all the different models that are available. There's the Anthropic models, so we could use those. We could use the Ollama models. So anyways, we're going to use today, I think, the Nova Pro model, which is an Amazon model. So anyways, we set that all up. We selected our models that we're going to use and what Josh is going to build, and then we set up your credentials so that we can talk to that model.
Yeah, I'm already authenticated. You wouldn't believe it given the mess that was the first minute of this talk, but that was done. What I failed to do was to log into this console, and Amazon decently and usefully protect you with MFA. And guess what I was trying to do? Just a second ago as we got started. So we have a lot of different choices here. That gives you portability. You don't have to change anything but a config bit in the application to choose which model. When we talk about models, of course, who knows what an AI model is at this point? Come on, anybody have any questions about this yet? Okay, good. So there's lots of different models: images, transcription, chat, embeddings, and so you can make those selections here and then specify or stipulate that. You have to enable them, like you just said, right? You have to actually enable this stuff, right?
You do, up until, they're making some change today or something where you don't have to do some of that anymore. So
yeah. Okay, so what we've got to do is we're going to build a new application, and we're just going to take a roving tour of all that is awesome in the Spring AI ecosystem. Go here to my second favorite place on the internet. Look at that internet working. Can you imagine? At this conference, that has been a hit or miss. We're going to build a new application. The question is, what are we going to build an application for? And I always like to, I always struggle with this. What should the domain be, right? What should we talk about? What should we look at? And so this time, I keep telling people about this terrible, terrible dog that I just love to hate, named Prancer, right? Who's terrible like my dog. I have a terrible dog as well. And so we're going to build an adoption service to help people adopt terrible, terrible dogs, okay? So here's what we're going to do. Go to here, adoptions, Okay. Build a new service. We have some choices we want to make. What version of Java do you want to use? Obviously, we have 3 radio boxes, but only one valid choice, right? Java 25 is the current version of Java. These other ones we just keep to see who makes terrible life decisions, right? These are not for actual clicking. You should never, ever use those, ever, in any context. Now, we're going to add some dependencies. We want the web support. We need to use the Bedrock dependency and then Converse. What's the difference there?
So Amazon Bedrock is the one that allows us to do the embeddings. It's kind of the foundational one. And then the Converse one is an API that's abstracted over all the different models. So no matter which model you pick to use, Converse becomes like one consistent API to talk to those models. So we had both of those, the Bedrock one and the Converse one, so we can do all the exciting things we're going to see. Did you already do all those? What else did you have?
I added the chat memory, the PG vector. So we have a choice. We decided what model we're going to use. We're going to store stuff in a vector store. There are like 20 odd different vector stores in Spring AI, and you can, there's a lot of them. Some of them are purpose-built vector stores like Milvus and Weaviate and ChromaDB and Qdrant and all that. But a lot of them are just things that you can enable in your existing data stores technology. So you don't have to go out and buy a brand new thing to get going. And so, case in point, if you want to use Postgres as a vector store, you can, and that's called PG vector. So we're going to enable that. We've got that here as well. I added the web support. We'll look at all the other stuff in due time, but I've just created that zip file here. Okay, I'm going to open that up. I'm using a little alias in my shell here, which points to that script, right? This is a little script. So if I cat which UAO, well, okay, which UAO. If I cat that, you can see it's
Oh,
what did I do?
I don't know what you did there.
Cat, whatever. Josh, env, Ben, unzip, and open.java. This is my favorite feature in Java 25, is that this is a Java script. Okay, this is a script written in Java. It's the only good kind of JavaScript. So if you see the other kind, reject them, okay? Notice that it's just a top-level thing, top-level method, no class like me, right? And there you go. So I'm going to open this up. We have to make some configuration here. Specifically, we have to point to the right version of the model. So I actually happen to have, because I forget the particular
those model names are hard to remember.
Yeah.
So we're going to
paste that in there.
paste those in.
Okay.
What do we got? We got our chat client. So this is when we do an LLM inference call. We're going to use the Amazon Nova Lite model. We're going to enable the chat model. We're going to, for embeddings, use the Bedrock Cohere model. We have to set up the PG vector dimensions. We have to initialize our PG vector schema. And then we've got the chat memory schema initialization in there and some database settings. Right?
Okay, all
That's
good.
it.
And I have a database full of, I've got a table called dog, and there's a bunch of dogs in there that are in this shelter that we're going to build a service for, okay? So here we go, adoptions application. We're going to build a simple controller here, class assistant controller. And the idea is that you can talk to our service to ask questions, to inquire about the dogs in the shelter. So we'll have a little endpoint here that can answer questions about the dogs, okay? So here we are. And we'll just create that. And this will be a simple HTTP controller, Spring MVC. And, I want to inject the Spring AI chat client, okay? The chat client is your one-stop shop for all things Spring AI. You can inject the instance directly and then build a bean and have that, or you can have different chat clients for different use cases. It's very common to do that, so no reason you couldn't. And I'm a big fan of the chat client. You know that, right? I'm a big fan of this chat client. I think only the best people worked on it, right? So clearly the best people were on this, okay? So there you go. So there's the chat client. We're going to inject that, yeah? And we'll say return this.ai.prompt, and then we're going to, pass in the question. That's a user prompt, right? We're actually, you could just say prompt, and then stipulate that this is the user prompt, or you can take the shortcut and just pass it in directly. Let's just do the long form, okay? And then here we are, okay? So I'm asking for the results to come back. I'm going to get the content as a string, and I'll send it on to the model, and then the model's going to answer questions. So let's just try it. Let's just see how much this buys us, okay?
That's where we get to test to make sure if you did everything right so
Everything so far, okay? And if you're following along at home, don't. Just or slow it down. It's going to be fine. Okay, so let's go to the console here. HTTP, okay? There's that, 8080. Ask question equals, and we have we have a bunch of dogs here. So look at that, PG password equals secret, and again, it's a secret, people. Don't tell anybody this, okay? My user, h localhost my database. Here we go, bunch of dogs. Select all from dog. And there's a dog that's like particularly fun, and there's actually an ad that was put out about this poor dog named Prancer, and he is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. So our goal is to eventually adopt this dog, okay? So now we got the service up and running. Let's ask a question of it. Let's say, do you have any, right? Actually, even better, let's just do something very simple. Let's just establish a dial tone, right? So question equals, my name is Josh. This should work, right? It's going to be fine, right? Here, okay, good. Look, we're connected.
We did an inference
dial
call.
tone, nice.
Yay. Okay, dial tone.
Fantastic. So the model and I are now friends. We've just met, but I feel like we're making good progress here. So let's just see what we've got. What's my name?
Oh, it's forgotten you already.
Why do I have this effect on people? I'm that forgettable. So obviously this thing is lost. It doesn't know who I am because these APIs are stateless, obviously. So we need to give it memory. Well, how do you do that? You propagate a transcript, basically, right?
Yeah. So we need to have some place to store this memory.
Yep.
And on every call that we make to the LLM, we need to send the memory to it.
Okay. So we got this. We have a property that we saw earlier. Here, saying enable the chat memory, okay? So it's initialized that schema for us. That's what this Spring AI chat memory is. And what we need to do is to use Spring AI's concept of an advisor. It's like a filter or a preprocessor that wraps calls to and from the model and allows you to do whatever you want with it. You can mutate the request, you can take note of it, you can log it, you can do whatever you want. In this case, that's exactly what we're doing, is we're taking note of every request and every response and storing that in a database, and then retransmitting it on subsequent requests. But we don't want to send everything, to get too onerous.
Yeah.
So let's, first of all, give ourselves a user context, okay? User, ask, okay? And then here, we're going to configure a advisor, a prompt chat memory advisor, okay? And so we have to, you know the name of the game here is to return this advisor, build, and then we're going to pass in the chat memory. var MWA is message window chat memory, because we want to only send, let's say, the last 20 odd records, okay?
So this will just create like this rolling window for our memory so that we don't just build and build and build. So there's some defaults to that. I don't know how many messages get stored, but some number, and you can of course customize that if you want.
Yeah, here we are. Good, and then pass that in here and there, and then put that in here.
So we're saving this into our Postgres database, the one that's running PG Vector, which we'll get to in a little bit. But of course you could use any data store that you want for where you put that chat memory.
I have a question. Who's using Postgres? It's so good. It's so good.
It's a good one.
Yeah, I'm a big fan. Okay, so there I've configured an advisor. You can do this as a default when you build the instance, or you can do it at the call site. We don't want to specify the advisor every single time, so we'll just default it in this case. But we do need to specify to which user to ascribe this particular conversation. So let's make that a path variable, string, user, right? And then request param is a question. So that goes here. And then we say advisors p.param chat memory.
So part of why we're doing this is we have to be able to get that conversation ID, and we want that conversation ID to be associated with the actual username that's specified here. So, in a real world, probably this is like a session ID or something along those lines, but.
Yeah, Java Spring Security Principle, that kind of thing. Okay, hello, Josh. It's nice to meet you. Okay, good. So that's worked. Now, what is my name? Okay. Okay, make sure we preface it with the user context.
You gotta use that key.
There you go.
Oh, I remembered you.
Finally. So you can see that table's been populated. We go here, select all from Spring AI chat memory. Fantastic, right? You can see all that is there. Delete from Spring AI chat memory. I'm going to need to remember to do that because sometimes it'll actually cheat. It'll actually look at the context that's been sent and use that to inform the responses rather than reevaluating the request and sending it onto the model each time. Okay, so, and which is good, cost saving, but it's bad for my demo. So, okay, so we've got this. I think we're doing good.
We're doing good.
But we have, it's too good actually. It's too useful. What we have here is essentially an open endpoint on the internet that's a direct pipeline to my Bedrock account, right?
Yeah.
And there's no focus, no purpose to this, right?
I can't wait to use your tokens.
Yeah, exactly. Like somebody could do their history homework with this dog adoption shelter, right? So what we want to do is focus it a little bit and give it a directive, right? And that's called a system prompt. And so I actually happen to have a pre-written system prompt over here. So let's go ahead and take that system prompt, and I'm going to, cat, desktop, misc, talk, system prompt, okay? And I'll cat it, and there it is right there, and I'm going to copy it to the paste buffer. Wait a minute, you know what? That's not right. I'm sorry.
This is about dogs, man.
There you go, better. Okay, so now I shall copy that to the buffer. And here we are, var system equals, put that in there, and system prompt is that, okay? So it says, you are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. And we are, by the way, here. There, okay? So see how I remember that? If there's no information, then return a polite response suggesting we don't have any dogs available. Very good, let's try it out, okay? So now we can ask it a very simple question, like, what's my name again? You know, whatever. It doesn't know because I deleted the chat memory, but you can see it's trying to steer the conversation back to adopting of dogs, right? It says, hello, I'm here to help you with your dog adoption journey. However, I don't have access to personal information because I did delete the memory. It has no precedent. So that's working much better. It's focused. Now let's see if it can actually help us adopt dogs, right? And okay, let's see.
That's what we're trying to get to, is we got to get our dogs in here.
All right.
So that we can get them adopted.
Okay, here we go.
Oh, Prancer.
Yeah, well, okay. It says we strive to provide loving and well-adjusted dogs for adoption. If you're interested in a specific type, please let me know. So it doesn't have any data, right?
Yeah.
That's not good. We gotta make sure that it has access to the data. The data lives in the database, right? And so what we want to do is take that data and put it in the vector store. Vector stores are data stores optimized from semantic search, right? That kind of thing. Is that fair?
Yeah.
Feels right.
Yeah,
okay.
feels
And so there's actually an in-memory one. Like it's not a very difficult thing to get right or to get working conceptually. Here's actually an in-memory version in Spring AI called the Simple Vector Store, and it's like 300 lines of code, and it's not even that. I mean, most of it is just cosine similarity, that kind of stuff.
It was probably vibe coded.
Yeah, don't say that. No. Actual math.
Mark says no. Definitely not vibe coded.
The doctor says no. Okay. Okay, so that's there. I wouldn't recommend you use it, but the point is you could get something, it's pretty easy to get these things working. And the other thing you have to consider is that when you store things in a vector store, you have to vectorize the data before it can be searched, right? That vectorization, that happens thanks to an embedding model, right? And so we have to use an embedding model. Oh yeah. Thank you. There are many different embedding models out there, but again, we're using PG Vector, and we're going to use Amazon's embedding. And we want to make sure that
So that's the Bedrock Cohere part, is
right.
that we're going to use essentially an LLM to create the embeddings, create the vectors for the dog data that we're going to pass in.
Yeah, and we want to make sure that the data that we get back can be fit into the table, right?
Yeah.
So I've got to specify the dimensions there. Let's see, I'm going to drop that table just in case. Drop table, vector store, okay? I'll let it recreate itself. And what we want to do now is to, when the program starts up, just initialize the vector store, okay? And normally you would do this as you're adding things to your system. You just do it at the same time, right? But, we'll just retroactively do everything at once. I need to write a little Spring data code here to talk to the existing table, string name, description, etc. Okay, at ID, we need a repository. I'm using Spring data JDBC, and I'm using Java records. I love Java records, just so much. I mean, such a big fan, huge fan, right? Okay, big fan. There's that dog repository. Okay, and when the application starts up, we'll say repository find all that for each dog. Okay, and I'm going to create a Spring AI document. Now, in this case, the text that we're going to store is so small that we can just put one little string there, and encode it, and it's fine. But a lot of times you get like freeform text, right? You get PDFs and files and whatever. So you want to tokenize it, and there's actually a whole hierarchy of tokenization supported in Spring AI. Okay, so dog ID, name, description, and documented.
Document.
Yeah. There. Okay, that's a Spring AI document. Good. And I will write this to the vector store here, list.of document. Now this feels okay, but something's wrong. You know, this is a document for dogs, so I shall call it a document. Okay. Okay, so that's going to start up. It's going to run. It'll take a little bit of time.
Yeah.
Okay, let's get that.
So it actually is going to call the LLM model to get those vectors for the document that is being passed in, and then we're going to store those vectors into PG Vector, and that's going to allow us to do the similarity search that we're going to get to in just a little bit.
Okay, and you can see, well,
It's a lot of
it's
of vectors in there.
It's not. It's only 18, right? It should be 18. There you go. It's done. Now I'm going to comment this out because I definitely don't want to rerun that each time, right? So if false, and the other thing I'm going to do is I'm going to configure another advisor so that the Spring AI will know to consult the vector store to winnow down to reduce the list to the things that are potentially useful, and then only send those off to the model for final analysis, right? So injecting the vector store here.
So what we're doing here is called RAG, and it's kind of the easiest way to get some data into this chat client so that then the LLM can provide that information in the chat conversation that we're going to have about dogs.
Here we are. And so now, I guess we ask it over here. Hello. What's my name? No, we want to find neurotic dogs. Okay. I don't know if I have it in my history. We'll do it live. Here we go. Do you have any neurotic dogs? Okay, question mark. Here we go. Hello, based on the context, we have a dog named Prancer. Okay.
It found the dog.
We found our dog, okay? The dog of our dreams or nightmares or whatever. Anyway, so Prancer is a demonic, neurotic dog that is man-hating, animal-hating, and children-hating and looks like a gremlin. If you have any other questions or need more information about Prancer or any other dogs available for adoption, feel free to ask. That's a nice paragraph of text. That's not an API. You don't build abstractions on top of strings, present company excluded. So what we want to do is take this data, and maybe if you want actually something concrete with a strong type, you want to pass that around your API, you can use something called structured output. So as an example, let me just create a dog adoption suggestion, okay? Int ID string name and string description, okay? Here we are. And we're just going to, just as an example, you could do this. We'll change this to that and build that, okay, pass that in, and reload. Here we go. So now when I ask the same exact question, I get back a strongly typed JSON object, right? Nice. And that's an integer, so I can now use that to correlate to the actual request that I got, right? So now I have you could do that, but of course you might have more steps involved, in which case you would probably want to keep it as text, or, we're going to go back to text. And I think the next question, what's the next, we found the dog, what's the natural next step?
We need to have some way to integrate this thing so it can actually adopt the dog.
Yeah.
Yeah.
So let's build our patent-pending super proprietary dog adoption scheduler component. Okay, dog adoption scheduler. And we're going to build a tool. We're going to give our model access to its environment. This is, I think, the most important thing here is what we're doing here. All of this is just about writing Spring applications that talk to our existing business logic and that talk to our existing data. This is where most of your stuff lives anyway. Most of your business logic, most of your data is being housed and protected and served by services written in Java and Spring. We have a wonderful opportunity here when you think about it, right? It's much easier to add these existing, to add AI integrations and hang them off the side of these existing services than it is to build from whole cloth in a whole other ecosystem and language. 99% of AI engineering is just talking to a REST endpoint, right? So we're doing that here. There's no reason this couldn't be done really nicely in Java, as I think you're hopefully seeing. So
okay, we got 1 minute to get this dog adopted.
Okay, var I equals instant dot now dot plus 3 days, okay?
So you're just going to simulate what it's going to be like to pick a adoption date for somebody to come and pick up their dog. So that's what our tool's not actually going to hook up to the actual dog inventory system. And so we're simulating that here for scheduling an appointment. This tool is going to take some parameters. We've got the tool parameter for the ID of the dog, so we can go look that up in our dog inventory system. And then we're going to take another parameter, which is going to be the name of the dog. Sure, why not include that as well?
Yep.
And so we can output that there. So this tool, we're going to be able to then toss into our chat client, and so that then, as part of the conversation that we're having with the LLM is going to be like, oh, the user is asking to adopt this dog. I have a tool that I can call to do that. And the way that tool call actually happens is the response comes back from the LLM. Spring says, okay, now I need to call this tool. It's going to then call the tool here, and then we're going to be able to do the dog adoption thing, and then return back to the LLM with the, hey, we've scheduled an appointment to adopt the dog.
Right. Okay.
And this is not using MCP yet, but that's where we're going next.
So last line here, tools. And
so you did a little bit of plumbing to like be able to expose that tool in a way that then can be integrated into the chat client. But now we should be able to go back to our, we're going to delete the memory. Don't forget to delete the memory.
Yeah. Do you have any neurotic dogs?
No.
What did I do wrong? Method tool callback provider. Oh, silly.
Oh, so close.
So close. And yet not. Okay, here we go. Dog adoption scheduler. That's what you got to provide. Okay. Okay.
Did you get it right?
Well, only one way to find out. Do you have any neurotic dogs? Yes, good. Thinking. Found Prancer. So now, fantastic. When might I pick up Prancer from the Antwerp location? Okay.
So if you did everything right, that should do our tool call. No.
What did I do? Did it default tools, scheduler, service, this is help.
Oh, we need to give it a description. That's how the LLM knows when it should call this tool. So it's not, if you have an empty description, it's not going to know when to call this thing.
And this is what your mom was always saying when she said, use your words. She's saying, well, document your AI inputs and prompts, okay? That's what she was trying to get you to understand. Here we go. Take 5.
Oh, do we need to first ask about?
Oh, okay, wait. I don't know. Let's see. Do you want to delete the memory again? Okay, and okay. Okay, got that. And then, when might I pick up Prancer from the Antwerp location? Yeah, here we go.
Come on. Hey, it worked.
October 11th. That's 3 days
It did
hence.
the tool call.
Yep, you can see that. Good.
I logged it.
So the natural next step, I think, would be I want to take that service and repurpose it. I need a protocol. How can I do that?
So we're going to dive into MCP. We got to switch.
Pit stop.
Do a little swap here. But I don't know, Christian, while I'm getting your laptop set up, tell us about MCP and where this fits into the dog adoption service.
Yeah, let's start. So far you've seen how easy it is with Spring AI and maybe some other frameworks to wire your resources, tools, vector store, semantic search into your AI application. So you as an AI developer, you are supposed to be responsible for this image. You have to define what are the resources, how to connect to them, how to interact with them, how the integration, how to configure the interaction with the LLM or orchestration. So this actually creates some additional. Spring AI makes it easy to do, but it is actually very hard to reuse. And this is where the MCP comes. It's a model context protocol. Actually, we have a dedicated talk tomorrow with Darius, so come and see in detail, in depth. And actually, there is another one with
we have so many
talks.
MCP talks
but
left.
practically, the purpose of the MCP is to solve this problem end-to-end integration. So it stays between the AI developers and the resources that are exposed and used by the capabilities that AI is using to provide, and it decouples and actually creates two, it creates two separate communities. I think this is very important separation of concerns. Now we can have the service providers, developers that build tiny wrappers called MCP server around their services. They know how to interact with their existing services, their API, so they don't have to know much about LLM, or maybe even not at all, but they expose this universal protocol called MCP, and then the AI developers now can actually build and focus on building their applications and focus on the LLM, prompt engineering, how many engineering there is, this is a different story. Right. But okay, all these AOM-related orchestrations, all these AOM-related stories, and it doesn't have to be bothered about how to add the capabilities, how to interact with these third-party services. This can be at start time or even a runtime updated and stuff. So this is two naturally separated communities. They collaborate and they can evolve themselves. And how can actually we extend the existing monolithic example of the Docker processor and introduce the MCP? Also, MCP, if you may have heard already plenty of stories about MCP. Most of the people focus on the tools, these little things over here, but MCP is much more beyond. It's a bidirectional protocol. It provides various other capabilities like resources, prompts, completions on the server side, and very important distinctions. Usually is who owns those capabilities. The tools are owned by the AOM. AOM decides when, in what order, and if to call a tool. You just can provide information to the AOM to let it know about this, but you have no control how actually the AOM is going to use the tool in order to extend its context in order to solve the problem, answer your questions. Resources, on the other hand, you can think of them as attachments. This is actually things that you as an application developer can use, read, list, and attach stuff into your prompt. Actually, this is you can use it either as a simple prompt stuffing, you can reuse it in more advanced track scenarios. Similarly, the prompts management, so again, they are owned by the users. On the client side, you can have very interesting capabilities like sampling and elicitation. So we're going to show how sampling works. Practically, the server side of the client, when you build it, can talk back to the server application, can talk back to the client via sampling, can ask and talk to the AOM via this application. So, and
one quick note.
Yeah,
so MCP, what probably most people have heard about it in the context of is AI code assistance. But you can certainly build MCP and use it in that way. But in this like dog adoption service, we're doing this like as an internal MCP server that's going to plug into our custom agent. And so you can use MCP for kind of a wide range of LLM integrations and different types of things.
Yeah, thanks a lot. While I was a maintainer of the SDK side, we actually been working and trying to figure out how to build these APIs at low level. On the Spring AI side, we've been trying to figure out proper usability by patterns and APIs, fluent APIs. So this is an example of how actually you can build an extended tool calls that internally can talk with ping, info, progress, can send different information, even performs sampling. And that's what we're going to do as an example right now. So I don't have much time to go to the life cycle, come to sequence diagram life cycle, but tomorrow we'll discuss this in details. And without further ado, how much time I have?
2 minutes.
2 minutes, okay.
1 minute.
That's enough. That's enough. So let's see how this idea. So I just picked the version of the demo that. You shared yesterday evening on the cocktail bar.
Plenty of professional time. Well,
yeah, so it's and here is the scheduler. It feels very similar, but in addition to the app tools which exist in Spring AI, it's also supported for the MCP servers. If you want to have more idiomatic support for the functionality that MCP servers provides, you most likely you want to use the specific MCP tool annotations. In addition to the parameters that we provide, we have this new context that would allow you in stateful service deployment to talk back to the client. In this case, we are actually extension of the same tool reservation scheduler, but now we are also sending information, progress. And what we're doing in addition, I was trying to figure out what would be the creative task that sampling would represent. What if we ask the LLM to write a haiku about this beautiful dog that we tracked on? Maybe this would
like a status update from the server?
Maybe this should improve the adoption rate or maybe decrease, I don't know.
Yeah,
right.
I don't know if I want a dog with haiku. And that's what it's happened behind. So we are actually asking on the server side when this tool is called, performing, where are we doing it? Info.
So in this case, our adoption MCP server doesn't have access to an LLM, but sampling gives us this hook that we can call back to the agent side that has the LLM, get it to actually run something through an LLM, and then feed that back to the tool call so that then when we get information on the neurotic dog, we'll get the haiku as well. And I think that's going to increase adoption rates.
And similarly, as the tools on the client side, we can actually inject a new handlers that would support this progress request, logging request, and sampling request. In this case, you can see when we receive sampling request, we're actually processing to the chat client, get the response and return it back to the server that would return the haiku and the stuff. So this is all running now. Hopefully it's initialized, and let's see how it works in practice. Okay.
Okay.
Let's see.
Ooh. Let's see.
Haiku time.
So we're expecting to see.
Okay, yeah.
Oh, okay.
We're
that
not
was
printing
just
it here, but
okay, we haven't done the sampling yet.
no, it actually happened, but we are printing it on the command line.
Oh, we're printing it out there.
So
Okay.
practically, we can see this is the scheduler.
There's our haiku, right?
Yeah.
A gremlin in the moonlight.
Yeah, if you
Schedule
see
with
it.
caution.
Okay, so you see that
Oh,
actually.
Prancer awaits home. A gremlin in the moonlight. That's a fantastic
He's a
haiku.
gremlin.
Okay,
Like,
so
yeah.
thank you very much, and that was from me. So I just wanted to give you some glimpse about the possibility and how MCP can help you to extend the AI.
And do you have the slides
Bring
ready?
up the slides.
Yeah,
Oh, yeah. We'll get Mark's slides up.
and now Dr. Mark Pollack.
So that's kind of your very quick intro to MCP and how that works
And
with
Spring AI
Spring
today.
AI
No,
today.
gotta go.
But Mark has been leading things to take things even further. And so just to give you a glimpse of where this is going in some of the ways, you got your slides all good?
Yep.
Okay.
12 minutes and
So
36
how do
seconds.
I full screen this guy?
Ooh.
Ooh,
Christian,
How do you do a full?
I only use Linux.
Oh, yeah. Maybe the green full screen.
Full screen it.
I don't know how to be
know.
full screen on a Mac. F11?
I don't know.
Wait. Okay.
How
This
many-
is hurting our credibility.
I know, God. But I'm a Linux user also. And so. Oh,
It's
No.
It's somehow worse. Okay, wait. View. No, that's not gonna be good either.
oh God.
Wait. Okay.
Okay. We're
All right, just make this the full screen.
Yeah. There you go. Just double.
I mean,
click.
just double click on the title bar,
Yeah,
right? There we go. Good enough.
Oh.
Hey, Jesus.
good enough.
Okay.
All right, I made it here.
You made it.
So I'd like to talk to you about agents and benchmarking and things we're doing in that area. So models got a lot better over time. It's kind of shocking. Completion to tool calling to reasoning to planning, and now we're in this agentic era. And they've gotten cheaper. They're following sort of a super Moore's law. I don't think people are really realizing how much the cost is going down, but in fact, they're not getting faster and cheaper, they're getting smarter. We haven't really thought about things. It's not like I can analyze a bigger spreadsheet. I can reason about the spreadsheet better. And so I'll call this the Smarty Pants law. It doesn't have a good name, but we really don't understand it that well, but it's increasing fast. And I started using Claude Code. This was my aha moment around agents, much like ChatGPT was an aha moment for chat. If you haven't used a tool like Claude Code yet for coding assistance, you really owe it to yourself to give it a try. This is the year where the whole ecosystem shifted, I think, for software development. As you can tell, I'm quite enthusiastic about it. So Claude Code, mostly known as an interactive CLI, but you can use it in the command line. You can give it -P, and you could pipe things, right? This is literally taken from the documentation of Claude Code. So you can pipe in your Git log, and then you can make release notes, right? This is incredibly powerful, right? Pipes and filters all over again. But really, what the pattern here is you're giving context, and then you're sending it off to an AI to analyze. And then what you should be doing is verifying if what it created was actually correct. So that's the pattern. So we don't really want to write scripts a lot, right? They're brittle. We want to write code. Unless they're JavaScript 2, TM, Josh. So how do you move from using these utilities in a scripting-like manner to code? Well, you write a wrapper, right? Really not that hard. Here's what it looks like. Agent client is this wrapper that, in this case, wraps the CLI for Claude Code. And it looks just like chat client, except it has different methods on it, right? It has a goal. Agents achieve goals. It has advisors. This is advisor is a judge, determines if what comes out actually passed certain criteria. And so this is an approach that Anthropic itself provides a wrapper, and they're calling it the Claude Agent SDK. Came out, I don't know, 2-3 months ago. They renamed it. But again, in terms of portability, we don't want to just interact with Claude. We want to interact with all of these tools. And boy, oh boy, are there a lot of them. I think that I've done my research. I think there's about 10, right? I think we support 6 now. So this gives you that portability to call into any of these agentic CLI tools with the same API. And you can bring your own, right? It doesn't have to be from these big vendors. It could be your own app, right? Basically, if you can run in a CLI, we can invoke it. And so this project is founded on this portable abstraction for calling into these agentic CLI tools. But it's not just the wrapper, right? And this is a community project. We have an organization called Spring AI Community. I blogged about it recently. You can look at it on the spring.io/blog. And if you want to know more about the agents sub-project in that community, then you can just go to that link up there. But it adds more than just this, let's say, portable agent SDK. It adds, some prompts and goals. It uses prompt template. Tools, so these tools are MCP aware. You can configure them to use tools, and we can propagate that configuration down into the tool. Context, helpers basically to retrieve information, like get stuff from Git, right? If you're code-centric, your world revolves around Git repos. Judges is a very comprehensive judge framework out there. A lot of them in Python, did extensive research, kind of tried to boil it down into the best of breed and make that available in Java. And last but not least, sandboxes. Where do you run this stuff? When you have the Claude Code experience in your CLI, it's on your computer. You could do rm-rf. Luckily, it isn't doing that yet. So, but if you want to reproduce it, and set up a reproducible environment, you can run it in a Docker sandbox. And we provide those two, and I imagine there'll be more to run it, a Docker sandbox in a cloud somewhere more efficiently. So this is kind of the flow. Basically, you set up you have goals, you set up context, there's a bunch of data on the file system. You're on an agent client, maybe you give it tools, you tell it to achieve the goal. Let's say it runs on your local machine. Out it comes, you judge it, and then you look at the result. And what's important here, and this is almost in many use cases replacing semantic search in the vector store you saw before, is just dump your stuff in the file system, tell these tools to read it, tell these agent CLIs to read it, and it works amazingly well. And people are starting to benchmark this stuff and see that they get great results. So for your use case, you potentially could avoid doing RAG and just use this very direct file technique, let's say, to give your agent the context it needs. So I wanted to make this easy to run, right? You can build your own, but there are some that we can provide out of the box. So for example, we can provide code coverage tool. And so JBang is one way you can say, I'd like to run the code covered agent on your GitHub repo of choice, and I'd like you to achieve 70%. And here's where the flexibility of the provider comes in. You can say use Claude, use Gemini, use AMP, whatever you want. So this is the thing that's always annoyed me at practically every talk I've ever attended on AI. How do you know what the people showing you actually works? Like, you believe them because they're smart people, but, trust but verify. So I looked into benchmarks, right? They're out there. SweBench is a big benchmark in the community. It's the de facto standard, essentially. And it has one use case. Given a code base and an issue, make a patch that resolves the problem. And you can look it up at swebench.com. And looking for the right way to say this, let's just say SweBench has problems. Here's kind of the most distilled version I can come up with of the problems. They call it SweBench verified. That's the baseline. Has an original data set. It's about 2 years old. It's Python-based data set. It scores about 70%. You change the data set. Basically, it has a program that curated the first data set. And there's a SweBench Live, which is constantly getting new data sets. And you give it a new data set of issues, and it fails. It's really weird. Same thing, there's a thing called SweBench Polyglot. They do the same thing, more or less. They try it on Java, and it fails miserably. So, it doesn't pass the smell test. How can you score 75% on your exam today, if it's testing your knowledge, and tomorrow you get, 10%? Probably because you go to a cocktail bar with Josh. That might be a reason. And then 7% on Java, and I've been using these tools, people have been. There's no way that this thing is failing with 7%, right? But these are published results. You can go look them up. So what's missing? First of all, the use case itself is just one thing. Software developers, we do so much more. It's Python-centric. And most importantly, it's not actually evaluating the modern tool set. The sweet agent that runs was written 2 years ago or 3 years ago. It's Python. It's about 11,000 lines of code. It is not easy to run either. There's a lot going against it. And so really, you can't just keep doing the same old thing over and over again. You can't run the benchmarks with the modern tools we have now. And so you can't improve what you can't measure, right? So we have Spring AI Bench. This is another companion project that goes hand in hand with Spring AI Agent. It's, again, a community project. You can read about it on those links or the QR code. So it inherits from the Spring AI Agent project the ability to run multiple clients. There's a series of tracks, right? It's going to measure multiple things. PR review, coverage, issue labeling, create new features. Pretty long list, We've only done the code coverage part just a little bit. I'll talk about that. But that's the roadmap, and I've been in discussion with various companies about how to increase that roadmap. Reproducibility, that's a big issue. That's a big problem in some of the benchmarks, generally speaking. So we can just clone Git repos that are well-known. You can run them in Docker sandboxes for reproducibility. And it uses agent client to run and judge these agents. And while we make it easy to run and prepackage some, the idea is you should be able to tweak it for your particular needs. So here's an example I did earlier this week. I cloned the Getting Started guide for the REST service and said increases coverage. So did a pretty good job overall, right? It added the Jacoco dependency. Awesome. It measured beforehand that it compiled. It was 0 coverage. And then it added stuff. And I gave it a list of best practices, right, in the prompt. And they all scored the same. They all scored 70%. I asked it to go to 70%, right? But some follow the instructions better than others, right? So Gemini, even I said, use BDD naming for the methods or use JSON path. Said, nah, I don't want to do that. Did something else. And so here you can see it's not just measuring a number. Did code coverage increase? It's how did it increase the code coverage? And that's an important part of the judge. So you can have an AI-powered judge that reviews it and says, did you follow the rules? And of course, you could have done this in a loop, but these CLI tools, right, they already have the agentic loop in, so that loop has been exhausted. So same prompt, same coverage, but different quality. So then how can you trust me, right? Just because I have a benchmark. Who's watching the watchers? And luckily, there's this great initiative out of Stanford called Better Bench. And Better Bench has a paper, these are researchers, and they found that most AI benchmarks fail, basic tests, right? So they're really calling people out. Oops, sorry. Yeah, so they have like 46 criteria, 4 stages. It's super detailed, right? And our intention is to align ourselves, with that. Make contribution easy, have public leaderboards. And so you can think of this as kind of like, hopefully you can get a grade on your benchmark, right? And see how well you're doing. And there's no watcher of the watcher of the watchers. Just ends there. So this is the big paradigm shift. We went from completing text to completing goals. We had chat client for completing sentences. Now we have agent client. It can complete goals. You can help ship you features. And so tools got smarter. And we're making this big leap now, I think, this year from chat to agents. And can't wait to see where we are next year. Thanks for coming. I know I went over a little bit.
My fault. Thank you, everybody. Who learned something new? Who had fun? All right, thank you. Please vote. I've been doing this a long time. I have no shame. Vote. Please vote. Thank you very much.
Yes, your vote counts.
Yeah. You were awesome.